Welcome to this YSL Excel VBA tutorial. This video is going to explain how you can create a pivot table based on multiple consolidation ranges. So the video is all about how you can pull together data from multiple different worksheets to be analysed in one single pivot table. To start with, we'll demonstrate how to do that manually using the pivot table wizard, just so you can see that the process that's involved and what sort of output to expect. Then we'll start writing code to reference multiple consolidation ranges, and we'll do that in a fairly static way first, referencing the exact cell references, before we can move on to the more dynamic examples. When we get into the more dynamic examples, we're going to be using arrays, and we'll look at how you can populate an array dynamically to build a pivot table based on all the worksheets in the current workbook. Just to wrap up the video, we'll have a quick little overview of how you can modify the data field that's generated, so you can change which function it uses, and also how to format the output cells. The starting point for this video is this Excel workbook called movies.xlsm. I'll get a link up for you to download it as soon as I possibly can, but it might take a couple of days for that to appear, so please do just be patient. The idea behind the workbook is it contains multiple different worksheets, one for each year between the year 2000 and the year 2016, and on each sheet is a simple cross-tab table showing information about the total running time in minutes of various films made in different genres and with different film certificates assigned to them. So you should see that if you flick between the different sheets, that the data on each is slightly different. Now what is consistent between the different sheets is that the column headings, or the genres, and the row headings for the genres and the column headings for the film certificates repeat across multiple sheets. What I'd like to be able to do is create one single pivot table that combines the data across all of these sheets, consolidated into one single table. Now it's possible to create pivot tables based on multiple consolidation ranges manually using Excel's pivot table wizard, but in order to access that you'll first of all have to add the tool to the ribbon or to the quick access toolbar. So just to very quickly show you how that works, if you head up to the top left hand corner and choose from the drop down list to customize the quick access toolbar, you can then choose more commands, and then if you use the drop down list at the left hand side, you can choose all commands from the list. What you can then do is scroll all the way through the list to find something called the Pivot Table and Pivot Chart Wizard. So it's quite a long way through. So there we go, Pivot Table and Pivot Chart Wizard. You can then add that tool onto the Quick Access toolbar by either double-clicking or selecting and clicking the Add button. Then when you click OK, you'll have a new tool available to select. Now using the Pivot Table Wizard is a slightly old-fashioned way to create pivot tables. The modern technique involves heading to the Insert tab in the ribbon and just choosing the Pivot Table button, and there's a very simple dialog box to fill in. But in much older versions of Excel, from Excel 2003 and earlier, the Pivot Table Wizard was the way you created these pivot tables. So I'm going to hit this Pivot Table Wizard button, and I'll get a slightly different dialog box than the one you'd ordinarily see. The nice thing about this is I get extra options that I don't see in the modern dialog box. So the option here that I want to choose is multiple consolidation ranges. I'm going to create a pivot table out of this rather than a pivot chart, and then click the next button, and then I get the option here as to whether I want to allow Excel to create something called a page field, or for me to create my own page fields. It's always more sensible to create your own page fields, you get a lot more control that way. So I'm going to hit the next button again, and this is the really tedious part of the wizard. I've got to essentially select each individual range of data that I want to go into my main pivot table. I'm going to do this relatively quickly just for 3 different tables of data. So for the 2016 worksheet, first of all, if I've got cell A1 selected, I can hit Control A on the keyboard to select the current region, and then I can add that to the list of ranges involved in the pivot table. I'm also at this point going to add in a page field. So if I choose the option number 1 down here, I can type in a field name or an item name for this page field. Just in this case I'm going to call it 2016, which will represent the year 2016, of course. What I can then do is click back into the range selector dialog box and then head to the next worksheet along and click on cell A1 and press Ctrl and A to select the range of data, and then click Add. You can see why I'm only doing this for 3 ranges of data, hopefully. If I then click into the field box there, I can type in a new item name, so this would be 2015 of course, and then I can head back into the range selector box and then click on the 2014 sheet, click into cell A1, press Ctrl A to select that region, hit Add, and then change the field so that it's 2014, or the page field item to 2014. Just to reassure you that the old values that I've typed in are still there. If you click through the different ranges you've selected, then you will see that the field item changes in the bottom here too. So this is pretty tedious. If I finally click the Next button and then choose to add this to a new worksheet and click the Finish button, I'll end up with a very basic pivot table allowing me to select between all of the different years I've selected, so I can filter for one particular year, or I can see all the years combined into one single table. So our job going forward in this video is to recreate that, but not just including those 3 sheets, including every single worksheet with data on it in this workbook. So to do this, let's head into the Visual Basic editor as usual, and in the VB editor let's insert a new module into the project. I'm not going to bother renaming the module, we're not going to end up with that many subroutines in here. But the first subroutine we're going to create is going to be called something like Create Basic Consolidated Pivot. Consolidated Pivot is what I meant to type. Okay, so the first thing we'll do is declare a couple of basic variables that will help us with this. So the first few steps are kind of very similar to the way we've created pivot tables throughout this video series so far. I'd like a variable that I can use to hold a reference to the worksheet that I'll add my pivot table to eventually. So I'll say dim ws as worksheet, and then we'll of course need a pivot cache as we always do, so I'm going to say dim pc as pivot cache, and then finally a variable to hold the pivot table itself, which I'll just call pt as pivot table. The first thing to do then is to create the pivot cache. So to do that, let's say set pc equal to this workbook.pivotcaches.create. What we'll then do is fill in a bunch of different parameters, and the first one that we need to fill in is the source type. So I'm going to separate this onto multiple different lines, so I'm going to use a space underscore, and then the source type parameter, which I'll name here, is going to be equal to an Excel consolidation range, so we choose the Excel consolidation option from the list. In previous examples we've used Excel database when it's just a single Excel table. We've used Excel external when we're connecting to, for instance, an Access database or a SQL Server database. But consolidation is definitely the one that we need in this case. We also need to specify the source data, although it's indicated as an optional parameter here. When you specify Excel consolidation or Excel database, then you do need to specify the source data as well. So let's have a new line and we'll say source data, and then think about how we can actually specify the source data for multiple different consolidation ranges. Now for this basic example, things are about to get just as tedious as they were when we followed the wizard step by step and we picked each individual table by hand. Because what we're going to do is write out all of the individual ranges of data that form the basis for this pivot table. Again, just to save time and my own sanity, I'm only going to do this for just 3 worksheets at this particular point, before we do the more complex version and look at how to generate the source data automatically. So for now, what we need to do is pass into the source data parameter a 2-dimensional array, and the first dimension of the array will contain the cell references that form the individual table, and the second dimension will hold the name for the page field item. So what we're going to do first is use the array method to start populating an array, and then below that we're going to have a separate array method that populates the 2 individual dimensions in the array. So the first thing we'll do, just to write this out by hand, is a string that we need to pass in here, and we need to refer to the worksheet name first of all. So all the worksheet names are called the year of the film followed by a space and then the name data. So to make that work, we have to wrap up the worksheet name in a set of single quotes, and we're going to say 2016 space data, then type in a single quote again to finish the worksheet name, follow that with an exclamation mark, and then we need to pass in the cell references on that sheet. Now, for some reason the consolidation method prefers the R1C1 format for cell references rather than the A1 format. So just to quickly look back onto the 2016 datasheet, that's going to be R1C1 to R5C6 for this first worksheet. So let's just specify that as well back in the code. I'm going to say R1C1 colon R5C6, and then close the double quotes for that one. And then if I type in another comma, I can then specify the name that I'd like to appear in the page field for that particular table. So in this case I just wanted to say 2016, so again that's going to be a string. I can then close a parentheses and then type in a comma and a space underscore, and then I have to do exactly the same thing for each of the other ranges of data, which is going to get really tedious. So I'm just going to do a quick bit of copy pasting here. So I'm just going to, in fact I'm going to copy that entire line, including the comma and space underscore, and then paste it in again down below. And then at the end of that I'm just going to get rid of those comma and space underscore and replace this with 2 extra closed parentheses. Because what I can do now fairly easily is just update the names of the worksheets to 2015 and 2014, and do that again for the page field items, 2015 and 2014. Then just to quickly check what the range of data is on each of those sheets, if I switch back to Excel and have a look on the 2015 data, that's R1C1 to R6C3. So I can just change that to R6C3. And then for 2014, just another quick check, that's R5C3. So going back to the code again, R5 and then C3. So you can imagine how tedious that will get to do the exact same thing for every single individual worksheet, but that's the basics of how you populate the source data for a consolidated pivot table. Now the remaining steps to actually create the pivot table are pretty straightforward, so before we start talking about more complex ways to set the source data, let's just have a quick look at the remaining steps required to create the pivot table itself. I'm going to start by setting ws equal to worksheets.add, so we'll generate a new worksheet on which to put this new pivot table, and then I can say set pt equals pc.createPivotTable, so using the method of the pivot cache object. Again, there's a couple of parameters I'm going to fill in. So the first one, the only compulsory one here actually, is table destination. And I'm just going to make sure that the table destination is cell A3 on the worksheet that I've just created. So ws.range A3. I can then also specify a table name, which is actually optional, but it's always nice to have a table name to reference later on should you need to do that. So let's have table name consolidated pivot. If I can spell consolidated, I should have picked a shorter name, shouldn't I? Oh dear me. Consolidated pivot, I'll get there eventually. There we go. Okay, so closing the parentheses at that point, all I need to do now is execute the subroutine to generate a new worksheet, and if I quickly look back into the Excel workbook, you'll see that it's got exactly the same range of data as the one that we used to generate, or the one that we used the pivot wizard to generate. So if I switch between those two, it's exactly the same stuff. Now, one of the main problems with the technique we've used so far to reference the ranges of data that go into the pivot table is that we've fixed the names of the worksheets and the ranges of data. So if somebody comes along and decides to update these worksheet names, or we get more data added into each worksheet, then this code is no longer going to be any use. We'll have to change it all. So as a slight variation on this, let's have a copy of this subroutine where we can actually calculate the worksheet names and calculate the ranges of data. So let's say create basic consolidated pivot variable data range. We'll start by changing the way the worksheet name gets entered into the array. So rather than typing it in as a literal string, what we'll do instead is refer to the code name of the worksheet and then use the name property of that to retrieve the current name of the sheet. So what I'm going to do is remove 2016 space data and then close a set of double quotes and then use an ampersand to concatenate to that ws2016.name. So that will simply retrieve the current name of the worksheet. So even if that had been changed, ws2016 is less likely to have been changed, much less likely that somebody will come into the VB editor and change all your code names for your sheet objects. So I'm going to use another ampersand then and concatenate that to the rest of the cell references. Then I can simply do the exact same thing for all of the other sheets as well. So if I just copy and paste this part of the code that I've just typed in here on top of 2015 data, and then just update the worksheet name so it's ws2015. So I've sensibly named or given code names to all of the worksheets in this particular workbook. And then one more time I can get rid of the 2014 data and replace that with ws2014.name. Getting dynamic cell references is a little trickier, but still possible, so let's have a go at doing that. First of all, I'm going to get rid of the R1C1 to R5C6 for that particular worksheet, and then just delete that part. I'll still need the closed single quote and exclamation mark, but what I'm going to do then is concatenate that to a bit of code that's going to retrieve the address of the cells on that sheet. So I can say ws2016, using the code name of the worksheet again, .range A1, so I know that all of my data begins in range A1 on the sheet. Then I can refer to the current region of that data. So as I was going through the wizard, clicking on a single cell and pressing Ctrl A, that was selecting the current region of those cells. What I can then do is refer to the address property of those cells. Now, one slightly annoying thing about the address property is that it returns the A1 the A1 format, or the A1 style of cell references, and we need the R1C1 style. So if I open a set of parentheses after the address, you'll see the third parameter there says reference style. So if I name that parameter, reference style, colon equals, you'll see that I can then set that to XLR1C1. So I'll select that and then close the parentheses. Again, I can then just do a quick bit of copying and pasting. So if I take everything that I've just typed in there, in fact including the ampersand, so WS2016 range A1 current region .address, copy that to the clipboard, and then on the next line remove the R1C1 cell references, and then just before the comma type in or paste in what I've just copied. I can then just update the worksheet name so it's WS 2015, and then do the exact same thing on the next line and replace that part, and then paste in what I've just typed in, and then change the worksheet name to 2014. So consistency here is quite important, of course. So on each of these sheets we know that the data begins in cell A1, but the current region property will now pick out exactly the range of cells populated on each sheet. The final thing that we should probably do is also update the way that we're generating the page field item. So rather than manually typing in 2016, 15, 14, etc., we should just use this to reference the name of the worksheet. So in fact I'm just going to copy and paste ws2016.name and then paste that on top of the actual literal string 2016. If I just do exactly the same thing for the other two, I can then just again update the numbers, so it's 2015, 2014, and again thanking myself that I'm only doing this for 3 individual sheets. And having done all of that, I'm just going to run that subroutine to once again get the exact same pivot table one more time. But just to show you, just to prove that it does actually work, so you can compare these different sheets and they'll all give you the exact same pivot table, just using slightly different techniques to set the source data. Now this has worked quite well so far, although it's quite tedious to type all this code in. It's starting to get a little bit messy. We're ending up with quite a lot of code in this one single parameter of the create method of the pivot caches collection. So what we're going to do instead, just to tidy things up a little bit, is to use a basic array to hold the range of values and then set the source data using the array that we've populated. So again, one more time, we're going to copy and paste this entire subroutine. And then once we've pasted it in, we'll change its name, so it's going to be called create basic consolidated pivot with array. Now for this array, we know exactly how large it needs to be. We know that it needs 2 dimensions, and that in the first dimension it needs 3 elements, 1 for each sheet, and in the second dimension it needs 2 elements, 1 to hold the cell references and the other to hold the page field item name. Now we do have a video on declaring and working with arrays in VBA that explains this in a lot more detail. So just to very quickly go over the basics, we're going to declare a simple static array, which I'm going to call AR, and it's going to hold 2 different dimensions. So the first dimension will have elements numbered from 1 to 3, followed by a comma. Then the second dimension will have elements numbered from 1 to 2. Then if I close the parentheses, I can declare that it's a string array, so all the elements will allow string values to be stored, and that's the basic array declaration. Now we can start populating the individual elements of the array. So to do that, we need to specify which element we're populating in each dimension. So I need to say AR, then open some parentheses and say 1, 1. And then in this case I'm going to make this equal to the range of cells in the first worksheet that I'm referencing. So I'm just going to copy and paste that. Absolutely no point in typing that out again. Not being lazy, it's being efficient, and that's what I keep telling myself. So array 1, 2 will be equal to the name of the worksheet, or the page field name in this case. So let's pop that in there as well. So array 1, 2 is going to be equal to ws2016.name. Now the rest of it is essentially exactly the same. So again, copying and pasting works wonders here. So I'm going to copy those 2 lines and then paste them both in. Then to populate the second element of the first dimension, I'm going to use worksheet 2015. So I can just update all the 2016s to 2015s, and then I can paste that pair of lines in one more time and then change the array to refer to the third element of the first dimension, and then change the worksheet to 2014 instead. Okay, so that should have got all of them. The nice thing about this, the wonderful thing about this in fact, is that I can now get rid of all this long complicated code that populated that single parameter in the create method and replace that with a simple reference to my AR array variable. So again, having done that, I can just run this subroutine one more time, and going back to Excel, we'll see once again exactly the same pivot table that we've generated 4 times at this point now. Now we've only added in 3 worksheets worth of data to this pivot table so far, and even that's been quite a lot of effort and tedious work. If we had to add in all 17 sheets in this workbook, that's going to be even more awkward. Plus it's not that dynamic or flexible. If we added in 2017 data and 2018 data later on, then things become even more effort because we've got to modify all the code we've written so far. So what I'd like to move on to is the most dynamic, flexible version of this procedure that's going to look at every single data sheet in the workbook and generate a pivot table based on all of them. To make this work, I'm going to set up a quick subroutine first of all that makes sure that the only worksheets in the workbook are data sheets, so it's going to delete every sheet that isn't a data sheet. So just to start that quick simple routine, I'm going to head back to the VB editor and have a new subroutine called something along the lines of delete all but data sheets. We'll do this just using a fairly standard for each loop like we've done in previous videos in this series. So let's say dim ws as worksheet, and then we can write a for each loop if I just give myself a bit more space to allow you to see this a little more clearly. Let's say for each ws in this workbook dot worksheets. I'll add in the next ws line just to make sure I don't forget that later on. And then I also want to make sure that I turn off the application's alerts before I attempt to delete any sheets. So I'm going to say application.displayalerts equals false. And I'll do that before I begin the loop, so it only happens once. And then inside the loop itself, what I'm trying to do is test which worksheet it is I'm attempting to delete, because I don't want to delete all my data sheets, of course. So one way I can do that is I can check the name of the sheet to see if it includes the word data. That's only going to work, of course, if nobody's going to change the names of these worksheets. If the word data gets removed from these sheet names, then this little subroutine isn't going to work properly anymore. It's going to delete the data sheets as well. So you might find some other way to test whether you're working with a data sheet. Maybe you could check if the value of cell A1 on each sheet has a particular value in it. So maybe you could make this a consistent value, for instance. Again, the exact way you do this will depend on how your data is set up. But for this particular example, what I can do is say, if not, ws.name like, and then in some double quotes use an asterisk as a wildcard character, and then the word data. So that will search for any worksheet whose name begins with anything and then ends with the word data. And if that condition has been met, then I can say ws.delete. Okay, so I've got 4 extra worksheets up here that aren't data sheets. If I were to just simply run this subroutine, I'll see that all those sheets have gone and I'm left with just my data sheets. Next I'm going to make a copy of the procedure we wrote earlier on using this array. So let's go back up and copy the entire subroutine and paste it in down below, and of course we'll need to update the name, so let's change it so it's called create basic consolidated pivot with dynamic array. So the idea behind this one is that we won't necessarily know how big the array needs to be when we begin the procedure. So let's remove what's in the parentheses in the array declaration. This will declare an empty array that won't have any elements or dimensions at all to begin with. So we can't populate them in the same way as we've just done there. So let's take away all those lines which try to populate the array. What I'd like to do next is ensure that the only sheets we've got in this workbook are the data sheets. So I'm going to make a quick call to the delete all but data sheets first. And then what I can do is redimension my array to include as many elements as are required to hold data for all the worksheets in the workbook. So the simple way to do that is to say redim, and then say AR, and then in some parentheses I can say 1, 2, and then all I need to do is say worksheets.count, which will count how many worksheets there currently are in the workbook, and as we've just said, we've made sure that that's only the data sheets. So 1 to worksheets.count followed by a comma and then 1 to 2. So that will create an array that's got exactly the right number of dimensions and elements to hold all the worksheets in the workbook. The next thing we need to do is populate each element of the array with the correct range of cells for the worksheet we're looking at. And to do that we're going to loop through the worksheets or the data sheets. But we're not going to use a for each loop to do that. In this case we're going to use a for next loop. So we're going to count through the index numbers of the worksheets using a simple counter variable, which means we'll need to declare a variable which can hold a number. In this case it's going to be an integer, so I've declared I as integer. And then once we've redimensioned the array, we're going to say for I equals 1 to worksheets.count. I could have stored that value in a variable if I'm referencing it multiple times, but as I've referenced it just twice, I think we'll get away with it. Let's add in the next I, and then what we're going to do is populate the individual elements of the array again, but this time, rather than saying array and then specifying the exact numbers to populate, we're going to use the integer variable. So the first time this loop goes around, we'll be populating element 1, so ARI, 1, and then we'll make that equal to the name of the cells on the correct worksheet. Now to make that work, what I'm going to do is head back up to the previous routine, and I'm just going to copy and paste the first line that we used there to populate element 1 of both dimensions of that array. Let's copy and paste that little bit of code. What I then need to do is update the reference to WS 2016, because of course that's not going to be that same worksheet each time. What I want to do instead is say worksheets, open some parentheses, and then use the counter variable. So I'm going to use my I variable here again to refer to the first worksheet in the worksheets collection. I'll need to do the exact same thing where I've referred to the range A1 object, so where it says WS 2016 there, I'll need to copy and paste that as well. And then I've got one more item to fill in, it's the page field name, so that will go into array I, 2, and I'll make that one equal to into worksheets I.name, so I can just copy and paste that one more time, and there we go. So that short simple loop there will process every single worksheet in the collection, all 17 of them in this case, and add each item to the array with the correct cell references and correct page field name. Okay, so if we just give this one a quick final test, if I run the subroutine and have a look at the worksheet that gets generated, hopefully this time you can see that we've got a lot more genres and certificates than we had last time. And if I look in the drop-down list for the page fields, we ought to end up with one page field item for every worksheet we've processed. So we can now look at any individual worksheet in here and hit OK, or we could choose multiple fields or multiple items by checking the Select Multiple Items box and comparing multiple different years, or just indeed show all the years as we saw previously. We could write code to do that as well, but I've shown you how to do that in the introductory video on pivot tables in this series, so that's just exactly the same as it was before. I think one thing that might be useful here is rather than just showing a count of values, which is the default data field that gets added, I'd like to change that to either a sum or maybe an average, and maybe change the caption that's shown in the top left hand corner, and maybe change the formatting of the cells as well. So just to demonstrate quickly how to do that, I'm going to head back into the VB editor, and life will be slightly easier here where we have a separate variable to hold a reference to a pivot field. So I say dim pf as pivot field, just because the IntelliSense tends to break down when you start referencing pivot fields and their individual properties. So what I'm going to do is I'm going to say set pf equals pt.datafields, open some parentheses, 1. So when you build a consolidated pivot table, unlike regular pivot tables, it automatically populates the row fields, column fields, data fields, and page fields area. So you can always guarantee there'll be at least one data field to reference. So, having set a reference to that data field, I can now change a few of its properties. So for instance, I can say pf.function equals, and let's go for XL average, we'll get the average runtime. I should then change the caption of that field as well, so let's say pf.caption equals, and then I'll say average runtime. And then finally I want to change the format or the number format of that field, so I'm going to say pf.numberFormat equals, then just use a bog standard Excel custom number format, which in this case will be 0.00, so the number will come out with 2 decimal places. So, having done all that, I can run this entire routine again. It will clear up the original sheet that I've just created here, but if I just click into there and run it one more time, have a look at the final results, and there's a reasonably nice consolidated pivot table. If you like what you've seen here, why not head over to the Wysl website, where you can find loads more free resources, including these videos, some written blogs and tutorials, and even some exercises that you can download to practice your skills. Thanks for watching, see you next time.